Hey everyone, welcome to another Lisp Study Group. I guess we're going to get started here. I'm your host, Ron Vadum with Atlanta Functional Programming. Today we're going to be continuing our exploration of Unix command line parsing in Common Lisp. Right now we're going to finish our discussion of the Unix-opts library. We got a little distracted last week with a little debugging session. Turns out it was a pretty simple bug that, thanks to one of our members, we were able to fix, and I'll show you that solution to you today. In addition, we'll complete the discussion on that library. There's a couple of other things that were not mentioned in that previous presentation on it, so I'm just going to go ahead and finish that up. And then we're going to discuss another library that I've been looking at, which is unix-opts. That's a newer library that came out in recent years. I think it was like 2011 or 2012. It might be even more recent than that. And that's a different library that's available on QuickLisp as well. It takes a different approach to command line parsing than what unix-opts provides. unix-options provides, and we'll show that to you today as well. If time permits, I promised you like last time, we'll attempt to try and cover UI-op as well. If not, we'll cover it in another episode. So last time when we talked about unix-options, unix-options, we had this issue here where we weren't able to get parameter data correctly from our Echo server example that we were coming up with. Well, as it turns out, I misread the documentation a little bit when I originally did this, and I was helped with, like I said, by one of our members. This option, the ampersand parameters, is an exported symbol from the package. So in order for you to actually use this symbol, you're going to have to end up using something like this. Otherwise, the macro expansion does not actually do what you expect it to do. It will create the option like a normal Boolean flag option just because it doesn't understand what it's doing. And worse, it'll take this ampersand option and think of it as another option that you want. It'll generate something that we saw last time, which looks like I just forgot to load up my... Apologies, folks. This occasionally happens when I'm running in presentation mode in Emacs. So, hold on, let me try this again. Shift-G, C-R. Okay, compile later. Okay. If we go ahead and macro expand this, we ended up getting what we saw last time, which is this ampersand and this ampersand parameters, because it's treating it as a separate parameter in the parameter list. So to fix that, you need to go and, obviously just, since it's a public exported symbol, it's part of the exported symbols list inside unix-options, you could just go ahead and leverage the unix-options : ampersand parameters in order for you to actually get a parameterized command line argument that you can then pass in parameters in the command line and then get them parsed correctly. One thing to note for folks who may not be comfortable, or somewhat forgetful like I am, if you're really isolating your changes, is you could certainly do something like this, which would also fix the issue, which is instead of doing this, you could also do in here, in the use package, if you're especially using a def package, you could say unix-opts. Sorry, not unix-opts, unix-options. And this will do the same thing. It will allow you to... okay, I have to restart my image because I just realized that I ended up causing name conflicts because of the fact that I was doing this earlier. Give me just 1 second here. Okay. So this will do the same thing by adding the use, which is the same as doing a use package inside the REPL, or if you really wanted to, you could have also done use package inside the package itself. Otherwise, however, that's kind of discouraged. If you know that you're going to be using a package, just go ahead and put it in the package description. It'll be useful. And this, in the macro expansion, will do the same thing that we kind of were expecting, in that it created a new port for us with a long name and a short name, and port options, and will generate what we're expecting in terms of when we're passing in command line arguments and get them parsed. It will actually take that value that's passed in by the parameter, and it will accordingly bind itself to the port value variable that is created on the fly through this macro. Okay, as indicated by this port here. And then within the scope of this macro, of course, the port is symbol is accessible and allows you to get the port that you're listening on. Let me do one thing that's important. It's going to make this a little bit more explicit. So a couple things that are remaining. So one thing that we talked about last time when we were using with CLI options is that with CLI options gives you the option of passing in argv. If you really don't, by default, it will actually go ahead and do the correct thing and actually take in argv if you needed it. But you don't need it. You don't necessarily need to do what we saw here. We could actually go ahead and unwrap this guy, and we'll get essentially the same thing. The one thing to note, though, is the usage. Oftentimes in your command line programs, you want to actually provide some sort of usage statement. Now, before, the way we were doing this, we were using print, like we were currently doing this. Well, this is typically what you would normally do if you were trying to do this by hand, but the CLI options library, as part of unix-options, actually gives you the ability to create custom usages that will take in the list of the command line arguments that you generate inside CLI options and generate a usage ceremony for you once you provide a format string. And I'll show you how you do this. Normally, what you could do is you can actually use unix-options print usage summary. And what this does is it'll take a format string and the list of command line options. Right now, for some reason, it is not showing up the actual arguments that can be passed into this. So let's see if I can get it from here. And what you can normally do is in print usage summary is it could take in, has a lambda list, a description, which is actually a format string like you would normally pass to format, and the option specs, which is a list of all the options that are available for you, and it will generate a proper help for you. You will never use print usage summary, at least from the examples that I saw this week, directly. You would actually use it through CLI options. With CLI options, as you recall, has these two optional arguments. The first one is the actual command line arguments that are passed in, which, why is my... Okay, for some reason it's not recognizing that I have this available. Hold on, let me see if I'm doing this right. Okay. There we go. Why did I just lose it? Let me do this again. I'm having some issues with my autocomplete and the signatures in my mini buffer. So I'll go ahead and explain this. There are two optional arguments that were passed into with CLI options, if you recall. The first one is all the CLI options are actually being passed in from the command line. It actually, behind the scenes, binds all that information to a global variable, and you'll get all that information directly for you. But then there's a second optional argument that determines whether or not you want CLI Unix options to generate your usage summary for you. And you remember when we actually did this with a nil or a true. Nil is the default. If we do a true here and we compile this, you will notice that if we run sorry, let me get myself into that. And if we run main without any arguments, you would notice that listening port is nil, and it would, sorry, if we pass in -h, and for folks who are wondering what am I doing here in my REPL, I'm actually mimicking what would ultimately be passed in the command line. Like if you used a shell, you would do /echo server -h, and it'll give you the same result. Right now, I'm showing you that we can actually also mimic this directly in the REPL. If we pass in this -h, you'll notice that it generates this usage string. Okay. Now, obviously, there's a couple things wrong with this usage string at first look. One, the actual name of the executable is wrong, right? Although we are using Common Lisp, and specifically in my case, I'm using SBCL with this, I'm not necessarily asking for it to actually spit out SBCL's options. And in fact, it's not. It's actually combining SBCL options with additional options that are provided here. What we really want is to be able to pass in some sort of usage string that would allow us to determine these particular options, and then display this this summary kind of in a custom way. Well, we could do this with the actual third, with the last thing that usage summary can take. Enable usage summary in this respect isn't actually a Boolean flag. It could take in either a Boolean flag like true or nil, or it could take in a format string, which is ultimately passed into print usage summary and with the option variables, and it will create the usage summary page for us. So let's do that. Let's go ahead and delete this, because this is not needed. And let's go ahead and change this to our usage summary. Okay, we got usage, we do -echo server, right? Because that's what our name is in the command line, port number. Okay, we're gonna go ahead and do that. And then if you guys remember your format foo, this is going to be a quick review. You can actually iterate very quickly in a format string by simply using format ~a, tilde the %. And this brace syntax, what it's doing is it's an iterative construct. I'll take in a collection, and it will go through and print out each option for you automatically. And then obviously we want to put in this, which is our end string, and it will go ahead and spit out what we're expecting, which is not of type list. Oh, that's right. There's one more thing we need to fix in order for this to work. Okay, so the reason why this piece isn't actually working is we're not entirely done. In order for us to actually use this format string, we need to actually correct our argument here. Okay, so right now, before we allowed with CLI options to generate the short name and the long name for us. Okay, So, but in order for us to actually have a much more proper usage inside Unix options, you can actually end up providing custom short names and long names for a particular port variable. And the way we do this is pretty simple. We take in, we first wrap this, okay, we're taking in a list, okay, and the first name is going to be the name that's going to, the value is ultimately going to be bound to. Then it itself is going to take a list of a couple of things, right? So this list here is going to contain a another, well, you can think of it really like a console, but it's going to be it's actually using the shorthand syntax for a list. The first thing is going to be a pair, an inner list, which is going to hold the name, the short name, like if you're using like the character to specify what the shorthand should be passed in, all right? Then you need to provide a long option, all right? So that's going to be the long name, okay? That's going to ultimately be used to take in a parameter, all right? Then what you need to do is you need to say that this thing is a parameter, so you need to provide a true here, okay? And finally, what you need to provide is a summary of what this is. So in this case, it's going to be port number to listen on, okay? And what this does is, let's make sure everything compiles, is if we look at the macro expansion here, is it's going to take each port, in this case, our P port is going to be generated with, you know, the port number information that we provided. H and help is already generated for us. It'll just say print this summary, as we saw before. And it will go ahead and then bind it as usual. So when we go ahead and run this, now, you should get, that's weird, hold on, how did I mess this up? I have this actually in a different file, and I got this working in a different file. Give me a second here. I must have messed up something here. Macro client dot. Where is it? Oh, my apologies. That's why I didn't do that. Okay. I forgot one more thing in my format string. Dummy. The @ sign is actually the part of the iterative construct. Now this should work. There we go. And I'm going to show you that other file in just a minute. But just to review, this is our format string. Okay. My apologies, I forgot that I needed the @ sign here to actually make this a proper iterative construct here. Otherwise, it would be a format. It would take in, as you saw, a list instead of an actual list of lists to actually go and deconstruct. What this is destructuring this inner list here, because as you can see clearly, this needs to be flattened, and so it needs to first splice that into a flattened list in order for it to actually go in and run through each option. Just like any other macro that you've seen in the past. So this is a much cleaner usage summary that we're seeing now, right? There isn't much to go through this. And this is now going to do what we're expecting it to do. It will grab the port. When it sees the port, this check here is obviously there so that if there isn't one, it will just exit the program. As you can see here, if we just provide main, it doesn't do anything. Really, actually, I should put this here. So this is cleaned up a little. So we get nothing. And then if we provide, obviously, a main with a port and our standard thing, it also has an import. Oh, shoot. Okay, give me a second here. Did I may have restarted this in another thing. Just make sure I don't have it running in the background. That's taking a really long time. Slide board connection. Okay. Let's do this one more time. Here we go. That's it. All right. And let's go ahead and run this here one more time. Okay, we now have our server. And let's go ahead and run this. Let's open up our client. So what I did is I went ahead and made a more complete example of this usage of the command line arguments and the parameters, just to give you more of a complete picture of what's actually going on. The one thing that is missing here is the Boolean flag that I had to complete what we were talking about, and that is, we could certainly have a Boolean flag here as to whether or not we're, running a certain flag that's being passed into the command line. And these Boolean flags, when you're using them, go before your actual, your actual parameters that are taking in different parameters, okay? And the main reason for this is get ops, if you recall, expects kind of like the Boolean flags to be kind of bundled together before they are passed into for parsing, because it's easier for position by position to just say, okay, the rest of these arguments are going to be all parameters. Everything to the left-hand side of the unix-options ampersand parameters flag is going to be a Boolean option. It makes auto generation and macro expansion much easier to do. Otherwise, macro expansion would require a little bit more work in order for you to reconstruct and reliably get all your Boolean flags and all your parameter flags to be separated from each other. Okay. And so we could just certainly add, a very dummy one on this. But in order for me to do this, let me first open up one more SBCL. Okay. And let me go up a level, go to the top here and load ordered threads. And I'm going to go ahead and do the same thing here so we can get rid of some of this other stuff so it doesn't clutter our discussion. And we can certainly add, I'm not going to implement the full logic on this, but we can, certainly add, like, say, a daemon flag, whether or not we want to, demonize it. -D is also an option here. The one thing to be aware of is that the -D is optional, so you can actually put a -D here, but the host name and port number are required here in this case. Let me actually go ahead and do this. Everything's loaded. And run this guy. Oops, sorry. RS. Okay. Main :h. Okay, so we now have our options about what our thing is. Now, in order for you to get a more complete version for daemon, of course, you're going to have to do what we did before, which is complete the information that's required. So you need to go and create /d daemon t whether or not to daemonize. Okay, so this is not there. And go here and you look at it, you get the same thing. Okay, and you know this will work the same thing as we saw before. This is just doing nothing more than passing in arguments to the host, and this is a standard, echo server that we're running through. So you're going to see that it's sending all this information. If we hit quit, it's going to exit the connection. The connection is killed. Okay. Now this, if we review what we saw here, and let's go ahead and quit this guy and restart it later on when we need it. Unix options kind of gives you a couple of things that has a few limitations, but it's a simple enough thing that you can just use it directly. It is a thin wrapper around the C get_opt library. We saw that it uses, in many respects, the same syntax for folks who are familiarized with the get_opt library inside C. It allows you to provide usage statistics and the ability to, separate between Boolean flags and parameter flags. You can provide both of those. You can provide long options and short versions of options and so forth. So all that's fine. It looks like it's what we would expect. But, there isn't much flexibility in terms of how do you set up multiple options. Like when you're adding a new option, this list here, for example, could get potentially unwieldy. Specifically here, as we could certainly see in this example, we have like what, 2 options, and obviously we could certainly maybe split this up a little bit, and you'll get the same kind of like, oops, grab this, start a new one. Okay. You can certainly use indentation to actually, separate the number of options that you're getting, but bottom line is this this has some limitations. You have to know the positional arguments. You have to know the format of how the arguments should be presented in this variable format string option spec sort of format. So it requires a little bit of a learning curve, but once you understand it, it's a fairly simple library to use. Okay. On the other hand, the library that we're going to be discussing next, it's actually following some more of what a lot of modern command line parsing libraries utilize. Specifically, the library that we're going to be discussing, unix-opts, utilizes kind of the ideas from Haskell's opt parse applicative, or even if you're coming in from Python, Arg Parse, which allows you to specify options. So let's go ahead and take a look at that. Let me close this window here so we can minimize the number of things that are being around. And let's go ahead and open up another file here. So I'm going to show you another Echo client that I created that uses unix-opts. But before I do that, I'm going to first show you an example that's straight from the source code. Okay, because I think it's important to see how unix-opts is kind of constructed, and then we can go ahead and update our Echo client example accordingly to actually add this information. So let me first go ahead and load up unix-opts so that we can actually go ahead and use it in this example and compile this example. So everything in unix-opts is in a shorthand namespace called ops. That's actually a nickname for the unix-opts package. It contains several different sets of exported symbols here. The define ops, the options, whether or not you're getting a raw argument, how do you describe an argument, missing, reparse. These are all missing, reparse, and skip option, and unknown option. These are all conditions that the Unix-opts library has added to allow you to provide handlers to them when you encounter it during the parsing process. It also allows you to it has conditions for checking whether or not you're missing a required option, or you're providing an option to your command line that is unknown. Okay, and as we will see in this example, it actually leverages a lot of these conditions and handlers using a handler bind once you as you're going through and actually implementing these things. And we're going to end up using this to extend the Echo client example to leverage this library. Okay. But to begin with, how do we actually define options? Well, unix-opts provides, through the define ops macro, this ability to provide a list in a very clear, concise way of key value pairs using an associative list, essentially, but where the key is some sort of keyword symbol, and then the value is a value that you can leverage. Each of these lists, if you will, represents a single option. Okay, the name of the option here is actually the key in the ultimate dictionary that is constructed when the command line are parsed. That's the key that you'll be using to look up for what was that what that option was set to. All right. The description is obviously what's going to be used for when you do -- help. It's going to provide some information about the option. Your shorthand is the same thing as get_ops. It's going to be going ahead and allow you to provide a key associated, and then obviously this is the longhand. Sorry, I was about to sneeze. You can see each of these options essentially provide all four of these, and it really helps if you end up providing all four of these to help the usage summary. Additionally, on top of these four basic ones, which are essentially all all needed for the display and actually setting up of a basic option, and in this case, this is you could think of verbose output in this example to be a Boolean flag. If you have options that require to be, a specific data type when parsed, so you don't get into these runtime errors of actually thinking something was passed in as an integer but really is a string. Unix-opts allows you to provide validation parsers essentially into the flag, and that is through the use of what they call Arg Parser. Okay, that's essentially something that it will take in the string ahead of time, check to see what it is, and throw up an exception if it's incorrect. Okay, an invalid requirement is provided. Also, you have these flags here, such as required, true, or not. That's helping what we saw, that condition there, that missing required option, those conditions to be available, so that those conditions are thrown and you can have appropriate error handlers associated with whether or not required options are provided or not. And we'll see shortly how one might utilize this, especially in our Echo client example, where we have two technically speaking, we have two required arguments that both need to be available for the code to execute. Now, the one thing I wasn't sure about in here is metavar, because metavar is here we go. Because the way the documentation, my notes describe it is it talks about required arguments. Specifically, a metavar, I'm just going to quote the documentation here. It says, a metavar is used if an actual option requires an argument, and this is used to show how it will be printed in the option description. So basically, in the description, you have this level here, where this level here represents the meta variable that's going to be used in describing the argument, and is used to actually match what's in the description with what's ultimately going to be bound. Honestly, I don't know if this is even necessary, and we'll see if this is necessary when we're going through some of the examples there. But I'm just going to mention to you that this is also available to match your descriptions and the meta variables that are generated. In code, I don't think this is ever going to be leveraged. The only thing you will be leveraging is this guy, and that is the key represented in the name. But we'll see shortly how one might end up using this other stuff. This is parser. Okay, yeah. So what does the ops macro do, the define ops macro do with all this information, with all these arguments? Well, it creates actually a data structure. It's a global variable. Well, sorry, it's a special variable that's internal to the ops library that takes each of these associative lists, essentially, and creates a top-level list of all these, and creates a separate option spec for each of them. And by option spec, I mean unix-opts has its own built-in option spec that's leveraged, and then it will go ahead and spit out these values. Okay, so let's see what happens when we run this. Let's compile it. It's compiled and loaded. So what is actually spit out? Well, I'm just going to show you introspectively what the options holds. And you can see each of these are actually options objects. And if you look into these option objects, okay, these are all constructed. Remember, this is doing a make opt, if you recall, make options, and each of those are a separate options object, a class. And if we introspect this, you'll see that this is holding all the information that we provided earlier, like whether or not, it has an Arg Parser, it has a validation, what its description is, what its long name is, what is the meta variable that's being ultimately going to be used in the help, what is the key name that's going to be used in the data structure when we go and parse the arguments, whether or not it's required, and whether or not we have a shorthand argument associated with it. Okay. Now that we have our options, we need to look at a couple of other things. Well, as I mentioned, command line options and Unix options didn't really show this, since it's pretty simple and passes it all into get ops. But command line options could be passed in malformed, right? We need some way of actually being able to handle them accordingly in pure Lisp. Unix-opts provide this through some of the conditions that I mentioned earlier. And This example code shows how one might end up leveraging these conditions. So, like for example, we might have a condition handler for checking about unknown conditions. Um, Ignore the when option macro for a minute because it's an anaphoric macro that we'll take a look at as to what it leverages has. It's just basically abstracting away some of the things that we need to actually grab a specific option. But the unknown option condition handler is leveraged when we're actually calling and binding get ops. All right. If you notice here, okay, if you guys recall what multiple value bind does, it takes in essentially a destructure, a function that it returns values, and it will destructure them into separate, return values or symbols that we can end up using within the scope of the multiple value bind. Here, our multiple value bind is actually handling itself through a handler case, okay, by providing some specific information and specific options that can be returned when you are hitting particular conditions. Okay, so in this case here, what we're doing is in handler case, we first call getOps wrapped in a handler bind. Okay, and that's because if it hits an unknown option, it's going to call automatically the unknown option function that we saw earlier, which ultimately throws that this option is unknown, and it will invoke the built-in skip option restart that would end up ignoring that in the parsing process. This is how you would make sure that you have a reliable parsing process for your command line options. Okay. Then each of these conditions, okay, is if getOps throws any of these conditions, okay, like missing arg or parser failed or missing required options. It's as you all remember how handler case works. It's going to take this case that was thrown by getOps and then do some default handling of this. So in this case, if we have a missing argument, it'll throw up an error saying, "Hey, options S needs an argument," and it'll go ahead and throw some sort of condition here. Okay, and if we end up leveraging, say, a missing required option, it's going to throw up saying that fatal, we didn't get this particular option, and the getOps flag will also will give you the appropriate condition, like whether or not -h wasn't provided, or in the case here, we have the required argument -level. If we don't provide that to our code, it'll end up throwing up this fatal error and so forth. Each of these, and this is really the key point that I wanted to get across, each of these conditions are already available to you. So you can just simply write your handler case according this way every time, and I think it has the majority of parsing failures that you want. Now, if there's one that is not in this list, you could certainly extend the library to add your own condition. But the point is following the same similar design that's available in Arg Parse, okay, in Python. This thing gives you the ability to catch an exception during the parsing process and then allows you to handle it ahead of time. Okay, unix-options, if we saw earlier, there isn't much in the case of what might happen if incorrect options are passed in. Usually they're just silently failed, because that macro, if you recall, it has with options there that don't it doesn't actually take into account what was passed in. It just simply says, okay, getOpt gave me this information because it's, again, silently passes that list of information to getOpt, grabs all that information and binds it to those variables that we provided within the macro, and we're just checking to see if they exist or not. So it's on us to actually go ahead and throw the appropriate error if something might have been bound and it's actually required or not. Okay, whereas this library actually handles some of that for you. So I haven't actually ran this particular piece of code because if I understood what this code does, this isn't actually a straight up. We may have to just load this into the image to run this, and we could try this out. The one thing that I want to mention here that that was related to the anaphoric macro that we saw here. Okay, and remember, this is an anaphoric macro because it's using it. It is a type of anaphora. If we go back and I defer you to our discussions on anaphoric macros from Let over Lambda for a more detailed discussion of using anaphora. This particular macro was essentially getting rid of all these lexically bound statements of grabbing a macro and grabbing an option and using it in a set of forms. And it's ultimately used to shrink this code so that we can simply write something like this, where we're basically taking the options collection that's provided. And this is a dictionary that has information that behind the scenes it can grab a particular option object. And the way it does it is it's using getF, and getF, if you recall, can take in a collection. So we could just pass in, for example, our options and an indicator, and it's going to actually not star options. Star options is our list of options. It needs to actually get the parsed options, and it will go ahead and compile this. It will retrieve that information and return it for you. Okay, so if it's available or if it's been parsed, it will go ahead and get added into this dictionary, this associative list. So let's try and actually run this guy. I have to go and remember how to actually compile and load. MCL. Yes, load this. Okay. I think it just killed the option by exiting. Oh, yeah, that's right. There you go. I forgot that we had that. So there's one thing that ops has that you can normally get from Lisp by just simply running a return. And that is, ops provides this function called exit, which is why it actually failed, because we have a required option that's missing, and so it's obviously gonna fail because we're not passing in anything. Okay, and again, it's getting this stuff from standard in, so you can't actually run this. But this ops :exit function, what it does is nothing more than it's pretty much self-explanatory. The one thing that is different is ops :exit actually returns a proper error code to the appropriate outside to the external world. So you can use your standard Unix utilities to actually run this particular example. And what the folks at on the project did is to run this example. They actually wrote a nice little shell script that would load the Lisp and then run the top level options based on what is passed in on the command line. This $@ is a shell notation for essentially collecting all the rest of the arguments and then creating a list on that before passing it into Lisp itself. And then behind the scenes, what example.sh is doing, sorry, example.lisp is doing, is it's using getOps, which actually takes in the optional options that are being parsed in, and it will then throw up the appropriate error on it. So we can actually look at how this might work by just simply running, say, once we provide options, ops : get ops, and then provide a list of options associated with this. And so let's say dash H, for example. Let's see what happens here. Missing required options, so I still have to run that one. So let's go ahead and provide dash L and see what happens here. We need to use missing argument for dash L, so I need to provide a value for dash L. Let's say this is going to be a 1. Okay. So what getOps returns is as is expected. You saw this when we run a dash H. You can't just simply run dash H because since level is a required argument, you still have to provide the level number and all other required arguments before actually running the help. Okay. So in this example, when we ran the dash L1, it just goes and first eats that information and then checks to see that we have a help, and then we'll go ahead and return this associative list that we can now use get F and our associative list and the indicator, and we'll get what we're expecting. This is a standard now associative list, so you're now just doing a quick lookup for each command line option. All right. So how might we leverage this in our Echo client? Well, we have a host name and we have a port number that we know we need to have both of them in order for this to work, right? But obviously we don't want to be as strict as this program, because if they're providing a dash H to understand what each of the information is, we'd like to print out the usage summary. Okay, so we're going to write a little bit of code to actually construct some of this information. Okay, so let's go ahead and open up Echo Client unix-opts. So I went ahead and copied our unix-options program, and I provided some of the basic information here. Obviously I didn't just some of the basic stuff. The one thing that's obviously missing here is this is required and this is required, and since port actually is a port number, we'd really want to have it to throw an error if we gave an incorrect information. So we want some validation. So let's go ahead and add an Arg Parser to this and say use parse integer to take in our string and then spit it out. Okay. So we now have, let's do a quick load of this. We now have our dictionary. Let me go ahead and do this and do an MCR, so that way we're in our same package as we would have before. And let's go ahead and instead of get ops here, as we have, we're going to go ahead and implement the proper handler bind. Okay, so let's recall what cases we should really handle. I'm going to go ahead and bring up the example as a template, has some of the arguments that we may want to leverage. And let's go ahead and do this other thing here. Let's wrap this. Obviously, if you're going to wrap code like this, go ahead and make it so that it's properly indented. That way, your maintenance programmers don't complain about it. And we're going to run our handler case because we want, obviously, our handler case to be there. We may need to actually slurp some of the other code just in case, but I don't believe we need to because it looks like we're just handling all the cases. Okay, cool. So first thing first, we need to make this into a handler blind so that if we throw any unknown options, just like the case with the example unknown option, we're going to just go ahead and use the same kind of idea of running this condition, okay? And we want to use the same skip option that is provided in here. So we're going to go ahead and create the same idea in our code that takes in the condition, goes ahead and says warning unknown option tilde s. And we're just saying ignoring just so that the user is aware that we are not actually paying attention to this argument that's what's passed in. Okay, and since this was already parsed into our code, we can actually grab from the condition the option object that was constructed. Okay, every time in this library an option is parsed in, you are not actually getting a physical string like we did in unix-options. You are getting an actual object with all that information available to you. So here we're going to grab the option itself, and that's the string that's going to, it does a conversion to actually convert it into a string, and we'll end up using that. Now we're just going to go ahead and, just like in the other code, we're just going to call skip. We're just going to invoke that restart. And that restart's associated with some handler case that's behind the scenes, if you remember how restarts work. That's associated with some sort of lambda. So we have this. We're going to go ahead and leverage this in here. What's it? It's option, I think is what I have to do. Right? Yep, it's because it's associated with this. Okay. So now we run this. We have our case here. And now we need to obviously, this is weird. Why is there's some indentation issue here? Let me just do this. Okay, let's see if this gets corrected later on. So now that we have our options, we need to handle all the special cases that we saw here, like options, missing arguments, options, whatever, okay? So each of those takes in a specific condition name. In this case, we're saying, say, missing argument, condition, and it's going to have essentially a prog-n. This is an implicit prog-n on a series of statements that's going to be run in sequence with each other, okay? So here we are going to be, in this case, we're just running a single statement saying fatal needs this particular thing needs an argument, just like this example here. So we could just grab this piece here and then just leverage it. We can make things probably a little bit more cleaner. Needs an argument, and provide the options condition. Okay, so this one is there. In the case of the Arg Parser failed, you want to grab the raw argument itself and the option that was passed in. All right. So we can go ahead and do the same thing. We'll just grab in the condition. We'll just say argument s parse failed for value. Okay, and the reason I'm changing some of this stuff is I don't. When I read this example, some of the errors just didn't make much sense. So I'm trying to clean up some of this to make it a little bit more appealing. So we need, in this case, the option first, and then we can pass in the raw argument of the condition. And the raw argument of the condition is passed in the construction there. Okay, now we talk about our required arguments. Missing required option condition, and say required option S is required. Please provide a value. Okay. And oops. Let me take this guy out. And as usual, I messed that up. Option condition. Okay. Now, in this case here, though, we don't want it to necessarily spit out the argument as being just a required argument and then exiting. Okay. Although in the case of a normal execution, if you don't provide all the arguments, it might be useful to do what was done here, which is doing an ops exit with a 1, just so that we fail there. The one thing that's missing, honestly, before this exits is you want to do what a lot of modern command line applications require you to do, which is, or a lot of command line options do, and that is spit out the help. Okay, and the way to do that with unix-opts is, where is it? It is in there is a way of actually grabbing the options, and that is in, where is it? It is returns a string describing all the options in the program. Okay, so we need to use describe to actually do this. And describe actually creates what you would expect. Usage it'll describe all the options in the program, and then it'll spit out what we're expecting, including the usage. Although we may need to change the usage of the name of the executable, we'll see that in a minute. Right now, it's going to be whatever the default is for the program, and but this is already now up to kind of what we were expecting. Okay, right now we're gonna go ahead and run this guy without any options so that we could see what happens. In the case of hostname import, it should complain that hostname is not provided, and unbound condition slot. Something, I must have messed up something here. There is a condition slot that I have messed up. Let's see. There is something that is missing. Unbound condition slot. Okay. It's because we are not checking to see if there aren't any arguments that are passed in. Okay. Let me do this because really we don't need, but we can also optionally do that. Over okay, this is already going up in the wrong listener. This is processing everything in Slink. Interesting. Okay. Let's see what is. Let's try it with an argument. -h. Let me see something. Get ups h, and it says required hostname import. Okay, that's right. Good. Let's see. Where is this failing? This is creating handle options. Failing on the Arg Parse here. here. This is gonna be options condition. Okay, I think I figured it out. There is an issue with the unknown option. Let me see what this is doing. Let me do handler bind without doing unknown option this way, and instead making it an actual condition. And have this guy just do a fun call on our unknown option. And have the condition passed in. Ah, the problem is missing required option. Okay. It wasn't unknown option that was giving us an issue. It was missing required option that was giving us an issue. Unknown. Let's go ahead and keep that. Go back to missing required condition. Go here. See what I messed up here. There we go. It's already passed in. That's the reason why. Okay. Okay. Let's see this. All right. Oh, shoot. It did it again. I forgot that it would do this. But, okay, this at least tells us a little bit of the information, and that is not at all what I was expecting. It was giving me the condition rather than the actual name. Okay, so we got to correct some of this. First, let's go ahead and do this condition here. That's a condition object. Sorry. Create a new one. Go ahead and update this. Okay, here. Load your us. Here we go. Okay. So, if missing required option does not have the name, and we know this here is giving us an error. We need I can use dash A, will be what I instead of dash S. Let's try dash A. Sorry, tilde A. This. For now, we're just going to keep this guy commented out, just so that we don't exit out of our code. But really, you should have that exit so that your program will actually exit the status code correctly. Okay, and let's do this here. We run it, and it still says that there's no option, but thing is since it's passing in Unix required option here, is there any information that I can use? Okay, so missing options is what I need to use. Okay, got it. Quit. Okay, let's go ahead and fix this. The following options are required. Tilde at tilde A tilde okay, then we just need to provide missing options, and that will handle that. Then we can just go ahead and describe it. Okay, and there we go. Oh, dang it, I have to do that. Can't just simply split those up. I have to go in and actually provide information on those. Let us change this to being a list that we're going to collect. Okay, loop for option in our missing options. Okay, collect opt option option object. And I don't believe this is going to work, but I'll try it anyway, because it looks like I don't think I have access to the name. Okay, so let's see if this works. Okay, so we're collecting all the names of it and then just spitting them out. Okay, what now? Okay, it's not liking that. How can I grab those missing options in the condition? That's going to be in, let's see, missing options is a method, option is a method, but option is also a class. Let's see if I could use missing options on the condition. It says that it just takes in the missing options, but it doesn't tell me how to grab from the class their name. I guess I could use name, because it looks like name should be available, but it's not in the list of... Let's see if I can do this. Instead of collecting this, let's do this. Instead of that, let's see if I can use unix-opts. Name's supposedly supposed to be available, so you can grab the option name from it, but for some reason it's not showing up as a exported symbol. But we will see if I could do this, because there's multiple ways of skinning a cat, and we'll end up getting this. And this is what we kind of wanted, actually. The one thing to note here is you want to actually provide a usage, because notice here there isn't a usage. Okay, what I mean by usage, I mean an actual command line option that says the name of the program, the name of the what's it? The arguments that are passed into the program and so forth. This is all typical stuff that you would want in your usage ceremony. So to fix this, we'd have to go into describe in opt describe and then use the keyword usage of to provide the name of the program. In this case, we're calling it a client unix-opts. Okay, and obviously here you could provide additional things like -h or -h hostname. Actually, you could do this -h or --hostname equals hostname, and obviously -p or -port equals port number. Okay, and what this does is something of the following. If we run it, you'll see that it will create what we're expecting, and it's nice. It looks like it generates some of this for us, so we can clean this up, because I didn't think that was thing. That was a bit surprising. So I can actually go ahead and do this, and this REPL ends up giving us what we expect it to do, which is tell us the name of the requirements and the arguments. And one thing to note here is now if we go ahead and pass in any variable, and let's talk about the Arg Parser for just a minute. If we pass in, an issue, for example, with, let's say, passing an invalid port number. Let's say we say -p, but we accidentally pass in the host. Okay, you're gonna end up getting an error as you expected, because you didn't pass in the right value. One thing to note here, it looks like I forgot to put in a new line. And now we have everything things. Notice that we are let me get rid of this because this is no longer needed. Now, we're going to get the correct error messages that we're expecting. All right. And as usual, I'm just going to show this to you. If we go actually and do our normal things, we're now connecting. Ooh, wait a second. This is wrong. I got a string instead of a value. That means my argument in hostname needs to actually get Arg Parser. It's not an actual, it should be a proper string. It's not a Boolean flag, which is why I'm surprised it's set as a Boolean flag. Let's go ahead and say, wait, what is describe parse name string? I don't think I'm using the right one. This is compiled function. Let's see what parse name string does. Just gonna throw an error. This is gonna give me the freaking path name. That's not what I want. Let's see. There is a way to make sure that it doesn't give me a true. It actually gives me. Let's see what happens when I use opt, get ops. Well, first off, let me go and recompile this. Now, -h local host. -h is not a type list. Right. My apologies. I have to do X and slurp. Okay. What is it complaining about now? Missing required arguments, right? Okay, give me a second here. P 5000. Okay. This is wrong because hostname isn't just going to give you -p. We need to fix that. There's one thing missing here for giving parameters into strings. So let me see here. If an actual argument must take in order to supply this, it must be a function which takes a string and then parses it. I just want to echo the string, and if it's an invalid address, we can go in. We can always add in a proper validator. For right now, we're going to just use strict read read from string. Okay, we're not parsing anything necessarily, but there we go. That's it. So now we fixed our issues here. In here, the host name, because it's taking in a parameter. If it's not taking in a parameter like -h, or if it's a Boolean flag, just for it to being present in the command line, you're going to end up getting a true or false. All right, it just automatically sets that up. But if you are passing in a parameter, it looks like for strings especially, you have to pass in an argument so that it knows how to validate that. In the case of host names right now, when you're talking about server applications, which is what we're writing here, we're writing a simple Echo client server application. It turns out that you need to actually provide some sort of validation function to actually make sure that you're doing this. And it makes sense because of the fact that, as you can see in the case of port number, where we're passing in an integer, if you're expecting a particular format of a string, or you're expecting a particular data type in the case of port numbers, it would be useful to have that parser already available to you, so that you could get an arg parse failed like we had here, and you could write an appropriate error message for this information. So we now compile this. Now go ahead and run main here. As we saw here, everything is connected. We're getting what we're expecting, but we're getting now port is not of type sequence. Where is that coming from? Oh, one of the nice advantages of this is now that we done this, we no longer have to actually do these things. And this is another difference between unix-options and unix-opts. You're doing all your parsing and data validation ahead of time before you're actually passing in the argument into the function call that you're ultimately going to be using. This obviously addresses and solves a whole class of whole slew of errors inside the function. And you're able to pass in and deal with your command line arguments at the appropriate place. So get opt options. What? Wait a second. What is this? Okay, we don't need this. Okay, let's run this again. Okay, and what is this error now? Localhost follow the type case description. Might not be liking the fact that I am printing. I'm actually attempting to parse this guy. Let me see. Read line might give me what is actually passed into the stream. Let's see. Let's see this. Read from string localhost. Capitalizing everything for no other reason. Let me see something. String down case 1. Nothing should happen here. Alright, cool. So I can actually just, in this case, this is a dirty hack because it looks like read from string actually is doing something that I don't want it to do. Let's do this because we know that our string should always be downcased here. Because what's happening is a local host, if you have it all capitalized, it's going through an E-type case. This should actually do what I expect it to do now. See? Yep. Now we're going to get the standard ones. Okay. So, what have we learned here? A couple of things we learned here. One, we learned that unix-opts essentially acts like Arg Parse in that it creates options objects that I encourage you to go look at the documentation to see some additional information on what you may need to, what you could provide. The one thing that we didn't talk about today, mainly because we didn't necessarily need it, is providing a default argument. So like one idea is I could do this very quickly. If you know that you're always going to be connecting to a server on a particular port, you could put just a default and say 5,000. All right. And now this might be asking me to, which is oh, sorry. I have to make this 5,000. Now, if okay, my mistake. Okay, so the reason why it wasn't working earlier is because default arguments cannot be combined with required arguments. If you know that an argument is required, but you're providing a default into it, you don't need to make it required because of the fact that you already have some value associated with it, okay? You can obviously, if you're saying missing option failed or something like that, or unknown option, you can probably work around that, saying, okay, defaulting to such and such, and make the error messages or warning messages a little bit better. But really, honestly, this is probably going to be good enough. So this way, you'll see we'll get the normal pass, but you can also not have to provide this anymore now. You're just providing the host address, and it's always going to attempt to connect to 5,000, okay? And again, I encourage you guys to go look at the documentation for more information on some of this stuff. Like, we went through the majority of the construction of these objects. Again, what you're going to be using on a day-to-day basis is probably define ops to provide your list of options. You're not going to actually explicitly call out ops : make options like you would, just mainly because this ultimately generates that for you. Okay, there's no reason for you to go ahead and go through that exercise, and it'll go ahead and also return in that case the final values and set them up in the global namespace. Okay. The additional thing that unix-opts provides is this ability, and this really, I think, makes unix-opts a much more robust and much more mature library than unix-options. And that is, it allows you to essentially handle parsing failures in pure Lisp, instead of having to manually handle it yourself. And that's through its conditions that it provides, the built-in conditions that it provides for each of the different types of condition failures that you might encounter when you're parsing your command line options. Now, for folks who may want to have more flexibility in terms of writing their own conditions based on particular types of failures, you don't necessarily need to use the conditions that are provided in the library. There are ways of actually going in and defining your own conditions in the handler bind. But the point is that the machinery and infrastructure is there inside unix-opts to allow you to do some of that for yourselves. Finally, I think one of the big winners here is for folks coming in from other languages, especially unix-opts. It's much closer to code that you've seen in Python and other libraries in terms of its design. So if you're used to defining all your options up front and having a single place for your options, that isn't as unwieldy as you saw here with providing them all in the main function like we had here. Let me pull that up again for reference sake. In our Apple client, okay, here where you have it in this big list, where you're going to have to remember, if you recall, the position of how everything is structured. And again, this is a little bit of a learning curve, but it's not a big learning curve to actually go and correct. that alone being corrected with a simple named list makes it worth using unix-opts, in my opinion, just because of the fact that although this might be slightly, unix-options might be slightly faster, I mean, because it's probably leveraging the C library behind the scenes. Unix-opts, I think, has more flexibility and could potentially be used in a lot more other cases. Um, and it's probably a little bit more maintainable in the long run because you have these key value dictionaries that are available for you to know what each option is doing. And additionally, because it does built-in validation, you don't have to, like what I'm doing here in our Unix options example, parse everything and make sure that you get errors. Now, I'm not even implementing error handling here. In the Unix ops version, I was forced to, okay, because that's required in order for you to actually leverage a lot of the stuff. So yeah, there's more flexibility with Unix options versus Unix ops, but I think you'll get more robust code out of the way if you use Unix ops instead of Unix options. Again, both are available through Quick Lisp, and with that, I didn't realize that it's already over our 2-hour limit. So I'm going to stop here and take questions. Okay, if there aren't any questions, we're going to end it here for today. Thank you guys for joining. A reminder for folks, tomorrow we're having our Haskell study group at 1:30 to 3 Eastern Time. We're going to be continuing our discussion on type classes and finishing off essentially some discussions on some of the remaining type class examples that are in Chapter 6 of the Haskell book. I'm also going to try and see if I can sneak in some stuff regarding show. I don't think the show type class is actually mentioned it is mentioned in detail here, but it's a little bit more about reading strings and stuff. But there's information about this also in Learn You a Haskell that I thought was pretty interesting too as well. So let's I'll combine those two and let you guys know more about that. Also, another announcement, folks who are enjoying our discussions, if you have topics, please feel free to ping me or Judd Taylor. He's Dagmar on the Slack channel. I'm Buggerum on the Functional Programming Slack channel and Tech 404 Slack channel. If you have topic ideas, let us both know and we'll put you on our schedule. Otherwise, I'll see you guys next week. Bye.